We are moving quick. Look, at an elegant timing on the. I want to just wrote it down on a spreadsheet. Okay, the plan now is to do a little bit more directly with network analysis in R, and were a series of intro scripts on the webpage, and the thinking here is that each of you hopefully had a chance to see those and use them. And what I think we'll do this really quickly is John will just start a quick sort of description of what that is and what they do sort of at a high level. And then I think the plan is, maybe you should tell us. Our original thinking was that we would then break up into the breakout rooms and let anybody ask questions directly about their routine that didn't work. If folks didn't have a chance to, this is the part of the program that's completely like we're going cowboy here. We're not sure exactly what we're doing, so bear with us. If it's the case that no one, like that's just too cumbersome and no one had a chance for that work, then just like last time, it's sometimes nice to hear someone talk through something as they do it, and we can just let John keep going. So let's just get started, and then we'll see what the what the spirit of the room is. John, you want to take it off? Can I see a show of hands? How many people, just like roughly, just either show of hands or the reaction show of hands, who had a chance to run the basic scripts? My view gallery, there we go. I'm not seeing a lot of folks who said they were able to have tried to run it. Holding that.
Okay.
All right, that suggests to me that it might be most useful, John, if you were to just go through and talk to us about what we should know about this.
All right. Okay.
And maybe if it's possible, can you zoom in / increase your field size? I know everyone here has younger eyes than I do, but.
Okay, so basically increase the zoom in Zoom.
No, I think increase the font in our
oh,
studio.
in session. Okay, right. Hold on a second. Okay, so good call. So I think this is. Trying to remember.
It's in tools and global options.
Thank you. Thank you. Okay, there we go. I have to admit this one. And then do I do code?
Appearance, I believe.
Appearance, okay. Thank you. Right, so I'm gonna zoom it to 200. All right, is that better?
Yes.
Okay.
You might have to resize your windows as you go through, but.
Yeah, let me, oh, that's very large. Okay. Maybe that, can I get this? Oh, I see, it's trying to still help me, but it's very large. I want to maybe make it 150, but, or 175. That seems a little bit better. Monitor size, okay, fine, just do it already. Let me get to the bottom. I guess I'm adding. Oh, go away.
Oh, fascinating.
Well, I think we can still make this work.
Use the command.
Here, let me make this a bit larger. Okay, so let's start with some high level stuff and then I'll muddle through. First of all, there's two network packages that we're going to work with primarily in this workshop. And you can check if you've had, well, oh, it's really frozen. Okay, hold on. Let me bring this back really quick. It's, oh, because it really wants me to try to do this. Sorry about this, folks. I don't really want to add anything. Hold on. If I reduce this,
I think if you
just go ahead. I'll take any suggestion at this point.
Right now, there's an OK button or an apply that you can't see. It's off screen. So if there's a way to tab down to hit the OK button, just hit tab until.
Let me do it. Yeah, no, but now it's still super big. Or the thing's big, but it isn't. All right.
Try hitting tab a few times and seeing if you can highlight the button that's basically invisible.
Ah, good call. Good call.
There we go.
Thank you.
Then
It
okay.
takes a village and all that. All right. I think I can actually do something. Okay, good. Let me make this just a little bit smaller.
And for everyone, that's just a tiny taste of the sort of moments you find yourself when playing with this routine.
All right. Now okay. So let's first of all talk about, we have two packages that we're going to work with primarily. We're going to work with we're working with the family of packages, which is the network package, SNA package, StatNet. That's one family. The other is iGraph. You can check, do I have these packages? By simply doing this. And let's say I'll do StatNet quick. So statnet.com will actually get you the whole kit and caboodle. All right. One thing right now at the beginning, you have to decide at the top, which one am I going to use? Or you have to be very strategic about the calls. And the reason why, and I'll tell you what I mean by strategic as I walk through this. The reason why you have to do that is because the two use similar names, and if you load both of them at the same time and try to do operations, R basically doesn't know which package it should be working with, and you'll get errors and all sorts of problems, okay? So I want to talk about sort of the basic nuts and bolts of what a network is and how to get it in, and then maybe walk them how to actually do one from an example set. So there's the two major components are a node list and an edge list. So a node list is simply a enumerated list. This one's a super simple one, but you can imagine an ID. Ideally, for StatNet, it will not work if the ID is not sequential and not continuous. What I mean by that is don't have gaps, like 1, 2, 3, 4, 5, all the way down. iGraph is a little bit more flexible, but it actually comes with that wonkiness that Jim was saying, that it's also hard to get the IDs back out. So there's an ID, that's a numeric ID that enumerates all the nodes in your network. And then the label is, like, for instance, I just have 1, 2, 3 here, but you could imagine this as names of people or other more like they're strings, and they're more descriptive to give you a sense about, like, basically who are these nodes or what are these nodes. The other component, so this one last thing before moving out of this node list. This node list will be the size of your original data set, right? If you have a classic survey data set where rows are people, then the node list is going to have the number of rows that your classic data set has. All right, but your edge list is where all the action happens. I have more things in here than is ideal, but that's okay. I'll walk through the major elements here. I'll actually explain why some of these came about. Your edge list is indicating the ties. So I have I and J, and what that's saying is that node 1 is connected to node 50, node 2 is connected to node 18. You notice I have IID and JID. The reason why I had that was in my original data set, the dyad labels were not continuous and they didn't meet the requirement. So I had to basically I had to do some data frame management to get them so that I would have a continuous set of numbers. And we'll walk through that in a second. And then you usually have a weight column. And that's just many networks, that's just 1 or 0. In an edge list, classically, you don't need to supply the zeros. You just have ones, because if you have ties that don't exist, you've set the number, you've instantiated the network with the number of nodes. You give it the number of, you give it its edge list, it has the edges, and then if there's non-edges, well, no big deal. You can imagine, which is unlike a matrix where you would have ones and zeros. Anyway, if we go back here for a second and you go, well, okay, that I'm showing the node list and edge list because those are the sort of basic components that will then go into a network object. And so just because you make a node list or edge list, you actually have a few more steps after that. And let's like walk through that a little bit here. So I have to admit, it is kind of, all right, let me make this a bit larger because the console isn't going to be as useful here. All right. So wasn't sure I was going to walk through the entire bit, but we can do that. We had we had some example data. I think may see this data. It's this. It's basically ad health data that is synthetic ad health data, and when I pull that in, I'm going to walk through like basically what I do to make it work. Like, how do I go from a regular survey kind of setup to a network setup? All right, so I'm going to, all right, let me just, I'm going to import, I'm going to clear this out, very gutsy. And I'm going to just read in my CSVs with this data. So there's a couple of ways to do that. There's a run. You can also do on PCs, it would be Control Enter. On a Mac, it's Command Enter. And this is just going to be, this is like a little function I have that's bringing this in. It's okay. I'm just trying to get that we have some data to look at. And this is going to take a second or two because there's actually multiple communities that come in here. All right.
Just a
And
quick feeling in the room. Is this helpful for folks?
Or should we go more high level? Actually, let me see if I can see people's faces really quick. I can.
Someone give us a thumb up or a yes in the chat or some such if we know that this is useful.
Okay, so I have. Do I actually see? Oh, I ran the.
Okay.
Right. And then is that I can't even see my. I'm trying to see if I can see my. It's still running. My stop sign. You'll become,
Yes.
for people that aren't haven't worked at R a ton. The stop sign is telling you, okay, it's still doing stuff. Be patient, essentially. All right, let me limit Dana.
I think this is a slightly different version of the R code that was online that John you have here, right? This isn't the one that's
Yeah, this is actually right. Let's see if I can. Let's pull that. Actually, let's pull that. I will pull that directly. I had the sort of step before this. So if I go back to the workshop page and we go, we're looking at, not here. We're on this, right? This page, correct? My nodes, yeah, okay. So let me pull this in. And I can help explain what's going on here a little bit. And get rid of this text. I should use what people see. Okay. So we can walk through this and get this. The communities are still the same, I think the same data set that they were using. Or did they even do a totally synthetic thing? Oh, they're being nice. Okay, we can walk from this. So they're going to give you a synthetic data set. They're not trying to go from like a data frame. That's fine. But I think that's a good way to go. So remember we said we want this unique ID. That's what this ego ID is, 1, 2, 3, 4. And then our little synthetic agents have gender. And then because we're making little schools, they're going to have a grade. So one way to do this I'm just going to highlight this and I'm going to run it. And I'm going to go just some little R things. There's 2 ways you could look at this. You can go, oh, well, 3. 1, I can look at this little down arrow and I go, okay, good. This looks basically right. If I wanted to look at a little more detail, I can just double click like that. Or sometimes it's useful to simply say, hey, my nodes in the console like this. Of course, if your console is larger, that would be a little more helpful. So we have our little baby node list. And then, they're going to show you in JSON matrix. So this is helpful. So JSON matrix, I think it's easier just to make one and then show you what it looks like. So in this case, if I go, hey, this is a matrix. Why am I saying this is a matrix? So like as if that's a profound thing. It's because R is going to treat this a little bit differently than a data frame. So you see here, there's like no little down arrow. If I want this to be treated, so R will work with a matrix in a slightly different way than it works with a data frame. And for people that aren't as familiar with R or coming from a place like SAS or Stata or something like that, the object of SAS or Stata is always a data frame. In R, there are multiple objects and they have slightly different rules. But we have this nice matrix object. We have Jim, Molly, Leanne, Joe. If it's a 0, there's no tie. If there's a 1, there's a tie. And the complete network is represented here. But it's also a little bit of an inefficient data structure because we have all these zeros. So if we had many more people, we'd also have to have all those columns as well as these rows. And for larger data sets, that isn't really tractable. Another way to do it, a little bit more efficient way, is my edge list. Right? And then my edge list is like we were looking at before, except this one's nicer and clearer. So this is assuming, by the way, a directed network by the titles. It isn't, when we make the network, we'll tell it if it's directed or not. But here we have person 1, it has the tie of person 2. And oh, it's a weighted network. I know that because I have different numbers of these edge weights. And then in some ways, this means that this network is a little bit more information rich because I have, like you can think of these as like strengths of relationships or things like that. And thinking about iGraph and StatNet, we've talked about these 2 families before. There's an important thing here. In iGraph, this is treated like a distance. So it's how far away. So bigger numbers actually mean you're farther away from something. We usually in social sciences think of stuff as frequency, where 9.5 would mean 2 and 3 have a stronger tie than 2 and 1 have, the tie of 2. If you want that interpretation, you actually have to basically transform it. So you basically take the reciprocal of this to recover, oh, I want this to actually be a frequency, not a distance. In StatNet, it'll treat this like a frequency. So 9.5 will be the strongest tie. So we have this little edge list, great. Now here, okay, so they're gonna make this like a little adjacency matrix. That's fine. So we can look at this. And here, now this is yet another way. This is a little bit more. So the original JSON matrix was we had to have all these things. Here we have basically counts.
This is an event, person to event matrix.
Right.
Yeah.
Event 1, event 2, event 3 as these columns. And now from this, we can make a little bipartite graph here. So actually, we're making this subject, the object before that. So let's look at my little bipartite graph. This from earlier, we were talking about like affiliations. And so if we know that if both people are in, say, the baseball club, well, then in this network, they're connected, right? So that can be, and that's what we mean by bipartite. I know that when I hear bipartite, I often think about affiliation, frankly, or proximity. Identify, okay, these are good things.
This is a good, what we tried to do with this script was just comment the bejesus out of it. So it really is a tutorial
This is
script.
good stuff.
So,
all right. So now, now they're going to, we're bringing, okay. So I want to get to the actually make a data, like make a network object part really quick. And I think I still have, we can do that quickly here. We can even do that on the fly, which is slightly dangerous, but oh, did they do it here? Let's see if they've got the, okay. Yeah, well,
there you go.
right here, sure. This is all the data transformation steps for AHS. This is actually what I was about to dig into. I'm glad to see this in a little bit more clear-cut fashion. Okay. We have, I want to, okay, do I have community 1 still in here? Here's my communities list. Right. I'm gonna go back one really quick step. Here, I want to make community 1. And then we can, I'll just, all right. Sure. Okay, so I think we have these nodes and edges already. I'm going to fold some stuff up. Make this a bit clearer. My node, so we have my nodes and my edges. So how would I actually make this a network object? Well, let's just go down to the intro, go back to the code, data cleaning 2. And we're just going to do this on the simpler thing. And we can talk about these data transformation stuff in lab or stuff because just for the purpose of the time, because there's quite a bit going on here. Yeah, so now they're actually making this network. All right. They're doing the sender, they're doing this fine. They haven't actually made it, well, they've made it here. ID. Okay. This is just pulling this stuff apart. Okay. Well, they don't, where's the actual, I don't see their actual, where they actually, I see where they've made the, they obviously do it because they plot the thing down here, but.
Yeah,
As
doing it
network.
in
Okay, it's right
SA.
here. This is right here. This is what we want. So first of all, I'll omit this person. Okay. So this is an iGraph object. I'm just going to be really explicit. I'm saying I'm taking this from SNA. I'm doing as network. and they've got this little edge list, but we're going to go our edge list. We've got this little, let's see, my edge list and my nodes, just to give an example. This. And my nodes. Right. And I'm just going to check that there's any clue that they match at all. Right. So actually, we have to do a step before we go and do this. We have to do a couple steps. So for my nodes, I just want the ID right now. So I'm going to go my nodes and ego ID. And I'm just going to call this ID. Right. So that's actually going to be, it doesn't want all that information, it just wants the ID. We can add the label later as an attribute. And on my edge list, SNA actually forces this to have to be character variables. So let's go look at the little edge list. I may not have that as a character variable yet. Or let's go over here because it's so huge. So see, from my ID and PID, right now, these are numeric variables. This will not work if I keep it that way. So I'm going to take my edge list. And if people had trouble with this, well, if you ran the code directly, this was fine. But this often becomes an issue when you're actually working on your own network, like that you forget this step. So I'm just going to make this as character. This isn't the most efficient coding ever. I apologize, but this is going to be my edge list ID. I just want to check that I'm not insane. So I'm going to check the right-hand side. Okay, 1, 2, 3, 4, 5. Yeah, that looks all right. And good. And just check again that this is okay. Things don't look messed up. I have to do this for the other side too. So this is my 2 ID, right? Oh, I should actually make sure that this is actually from ID to be, yeah, like that. 2 ID, check that I did the right thing. All right, good. Ah, maybe this is actually character. Anyway, it's good to have this be really explicit because this is a frequent stumbling block. My edge list. And 2 ID. All right. Fine. Now, but my edge list, if we look at it, it's right now got too much stuff in it. And also, I have this extra ID variable that I made, but it only wants these 2 things. It wants from ID and 2 ID. So I need to get rid of weight. I have to add weight later if I want weight. So my edge list. How do I do that? Well, I just go, I want these 2 things. Just check that I'm right. Oh.
You're missing a G.
I'm missing a G. No. All right, let's check this again.
Gotta love
All right,
live
good.
coding.
All right. Now I can actually do this. All right. And let's see if this runs. I'm going to do test because I'm not confident. All right. Probably it didn't work.
All right.
Why didn't it work? It probably didn't work because as network isn't actually what I want here. So I go like this and I go, well, how about as edge list? I'll try as edge list SNA. That should work. Now let's try now. Okay, that looked like it Looked plausible. So now I have test. Now let's just check that test actually is real. Summary. All right, I've got something. And row, not totally confident. So let's do some other things. First of all,
Yeah, maybe.
I haven't,
Yeah.
go
Can you?
ahead, sorry.
No, I'm sorry. I think this is my fault for not having I was assuming we were going to do more breakout stuff here. So this apologize to John for putting him on the spot for this in no order, and to everyone else for a little bit of the disorganization happening here. You can kind of see some of the problems of trying to code, on the fly online while you're doing it in real time. Again, this is we were afraid this might be an issue. So again, I apologize for that. So I guess the thing to point out is, and it's probably obvious watching John do it here, is that the main thing with dealing with network data in R is that your two main packages are iGraph and SNA. And SNA and iGraph have different conventions and different rules for how you do things. So if you're going to create the network in iGraph initially, it has a way of creating a network object that requires a certain set of functions. And in the example code, we have ways of doing it both if you go through the details of those codes. And we just weren't prepped here to have this up and running on the fly. And so it's a little hard to see. I think the kinds of questions that I think people are interested in knowing is why you might use one versus the other, especially in the data manipulation phase of it. And I think the honest answer is you use the one that you're most comfortable with and you learn how to do, because the good news is you can convert back and forth between them. It does turn out that there are certain functions that you can only do in SNA and certain functions you can only do in iGraph.
Yeah, that's right.
And so you need to be able to move back and forth between the two of them. And that little trick you saw John do there that you might not have recognized he was doing, which is the name of the package : allows you to do that pretty quickly. There's another routine called intergraph that lets you move back and forth between the two and it works okay. But I think the best choice for you here, is to go through, and for those of you that are listening, is to go through and try to run these initial scripts on the page yourself. Do it tonight, do it tomorrow, do it next week. And if it works for you, then read all those comments and get the logic of it. If it doesn't work for you, send us an email and we will set up a one-on-one and help you figure out why it doesn't work. And I think that's going to be the most efficient online solution for this, is to really do it that way. And again, I apologize ahead of time, or behind time now, I guess, for not having this a better way to do this set of it. And so I think we'll focus more on the conceptual sides. Are there questions about this bits or what you saw there? I mean, again, I know that wasn't.
Can I bring up one thing quick, Jim?
Yeah.
The reason why that didn't work is because I did SNA and not network. And the reason I want to bring this up really, really quick, because this is something I run into. So on the StatNet family, there's actually 3 packages. There's network, that does all the basic network building. SNA calculates measures like total degree, n degree, as social network analysis measures. And then there's StatNet, which does inferential ergon stuff. And so as I was doing this sort of rapidly on the fly, I did SNA, that's the wrong thing. So if you do network, so basically the main thing I want you guys to walk away with is, if you're in this sort of StatNet family, if you want to build a network, you want network. If you want to get measures of a network, you want SNA. If you want to do inferential statistics on a network, you want StatNet. And as you can tell, it can be pretty easy to forget even that distinction when you're on the fly. So if you did network and do that, it would work.
Gotcha. There you are. The for those of you that can sense our befuddlement sometimes with this stuff, it is that there is all these packages were grown and written by their authors for the purposes that their authors had, not for the purposes that we had. And so as partial solution to this, what John, myself, Peter Muka, Dana, Pasquale, and I are all doing is we have a grant through NSF to essentially create a new network package, which tries to essentially be a linguistic simplification of a lot of this for analysts. And so with any luck, if you take this course next year, we'll have a beta version of that done that you all can play with that would make these kinds of distinctions a little less obtuse. No. All right, other questions or comments folks have?
I have a quick question. It's really good to hear the comparison between the different packages or the functions. I'm wondering if there's like a summary table or a resource that can help us clearly see the differences or similarities so that we can, you know, when we can triage it better when we're deciding what to use.
That's a good question. I'm not aware of one off the top of my head. Is anybody else, have they seen just like a table of functions that are in both, in neither, best for one, best the other?
There's like a nice site. I'll get the URL, I'll put it in chat in a second. That's basically like networks in R. The person's a bit of iGraph bias from my point of view because lots of the examples are iGraph, but they actually do walk through how to do things in both packages, and they talk somewhat about the relative strengths of them. So let me put that that link in chat really quick. And I found that to be a helpful resource on occasion.
Yeah. Any other questions of that sort of order that we could help with? And again, apologies for not being better prepared for doing the session. We just weren't clear on what we were doing.
Can I redeem myself slightly? Because I have it, it works.
All right,
So
show us
people
what you
can at
got,
least see.
John.
Thank you. I just would like a small moment of redemption.
Like my old
So
Catholic
can
school
people see
teacher.
my screen?
Yes.
Yes.
Can people see the screen? Okay.
Yes.
So we have my
Yes.
nodes, and they're like what we thought they were. Okay. So we have that back. And if we go, okay, I would like my little test data set now with network. So this actually, I do this double colon sometimes to be really explicit to myself. What am I doing? All right. So if I run that and summary, this is what an actual summary of a network looks like. See, notice you can see adjacency matrix up top. I did a bad thing though. You know what I did that was bad? I didn't say if it was directed or undirected. So I'm gonna actually fix that right now because you always want to do that. Just be really clear with yourself. What kind of graph am I talking about? Now, if I run this, I now have a directed graph. Good. And if I plot it, well, obviously I've done this before, so I'm gonna plot it one more time just to show you that. Okay, now I have a super small one. Let me give you one more trick about that. If you do this, this is just margins, and you go 0, 0, 0. On network plots, it makes it so you can actually see the network. There you go. Now, I have to say it's kind of an uninspiring network because I haven't done anything to make it interesting, but we'll talk about that over the rest of the workshop, how to make that better.
Amy has a nice question. Yeah, the reason the double colon makes it explicit is because what you're doing is you're tricking R into using a specific package to do the operation, as opposed to using the last loaded package to do the operation. And so if you have a code that it doesn't matter, this code would have run without the network, assuming the network library had just been loaded as the most recently loaded library. But if you have both iGraph and SNA and network loaded simultaneously, some of those packages arguments like as network or betweenness or closeness, some kind of common terms are in both packages. And what it'll do is use the last one loaded. And so by saying SNA : whatever, it's telling you to use that whatever from the SNA package as opposed to one of the others. Does that help answer the question? Awesome. No.
And the one thing why I said, hey, you want directed or undirected is that's one of the biggest distinctions in network analysis between undirected graph or directed graph. There are things you can't do on either kind of graph. So you want to be like, for instance, an iGraph, if we'll do community detection a little bit later. If you want to do Louvain community detection, it actually has to be an undirected graph. So you have to transform your directed graph into undirected graph. But as an analyst, just being really clear with yourself, what do I think this graph is a good thing. So it's just like little breadcrumb reminders as you're walking through the process. And if you're like, oh wait, it's not directed. Well, the whole time I thought it was directed, and you came back, and you're like, oh, these measures didn't make any sense. I have done that. So I'm just making this, want to make this point.
Awesome. Other questions? All right, we have on the schedule a 30-minute break. We'll come back at 12:30, and we're going to talk through strategies for exploratory analysis in networks. And so this will be, again, at a high level about visualization and things like this, as opposed to a code level. And we'll talk through sort of what you can learn sort of when you first start. And the goal is to figure out, you know, sort of in this process of doing analysis, where do you start and what do you try to figure out and what's useful. So everyone go grab an apple or sandwich or what it is you like for either breakfast or lunch, depending on which time zone you're in. And we'll see you all back here in a half hour. I'll leave the breakout rooms and the session open so people can come and talk to each other as they want.